So with this function, we're given f of x equals x to the fourth minus 4x cubed. We have to find the intervals on which f is increasing and decreasing, the relative extrema, the intervals on which f is concave up and concave down, the inflection points. Justify your answers and use the information you found to sketch the graph of f. All right, well, for increasing, decreasing, I would want to take f prime of x, which is equal to 4x to the third minus 12x squared. Set that equal to 0. I'll factor out a 4x squared, and I'll have x minus 3. So I have critical numbers at 0 and 3. If I take a look at 4x squared times x minus 3, to the left of 0, I'll have a positive times a negative, so that's going to be a negative. Because I've got an x squared term here, I'm not going to change my sign, but I'll just double test it. I still get that negative, and then if I were to try a number to the right of 3, lo and behold, I get a positive. So we know we have a relative min at x equals 3. The relative min value is, and I would go back and evaluate f of 3. Well, notice that's the same thing as x to the third times x minus 4. Well, 3 to the third is 27 times 3 minus 1 is negative 1. 3 minus 4 is negative 1. So that's going to give me negative 27. So that's my minimum, relative minimum value. Now, for concavity, so this would be, I guess my B is my relative extrema. C, from minus infinity to 3, my function f is decreasing. From 3 to infinity, f is increasing. So now I will work with C. This is A. Okay. So if I want to find C, my intervals on which my graph is concave up, concave down, I'll find the second derivative. F double prime of x is equal to 12x squared minus 24x. Set that equal to 0. See, when f double prime is 0 or undefined, it's never going to be undefined in this case. So I'll take 12x times x minus 2. And I am going to get a change in sign both times here. When I have a negative 4, I'll have a negative times a negative, which is a positive. If I plug in a 1, I'll have a negative. If I plug in a 4, I'll have a positive. So that means for C, the graph of f is concave up from minus infinity to 0, union 2 to infinity. F's graph is concave down from 0 to 2. I would have inflection points at 0, whatever that is, and 2, whatever that is. If I plug in a 0, I get a 0. I plug in a 2, I'll go back here, that's 8 times negative 2, negative 16. So those are some points that I know are on the graph as well. So if I were to go, I would think about my function, hey, we know that the graph's going through 0, 0, and 2, negative 16, as well as 3, negative 27. So here, I'm going to go to a graph, and I'm going to make it so that I can see negative 27. So at 3, I'm at negative 27. So 1, 2, 3, I'm down here. At 0, I'm at 0. At 2, negative 16, I have a point of inflection. So that's happening there. Before I get to my 2, okay. So my function is going to be increasing from 3 to infinity and decreasing from minus infinity to 3. So let's confirm that by plotting this function. You're going to graph it out. I'm kind of making sure my time here is not going to get a hold of me. X to the fourth minus 4x to the third. Boom. So notice this function decreases, but the graph is concave up. But then we have a change at 0, and the graph continues to decrease, but it's now concave down and it's still concave down all the way to 2, -16. And there you go. That's the gist of the problem. I hope that wasn't too much stimulation there.